Each year, between 75 and 100 people die in trenching and excavating accidents in the U.S. Most of those deaths occur when trench walls collapse on workers. The sad fact is, all of these deaths are preventable if you follow proper safety procedures. If you're an excavation contractor or work in excavation, maybe you're thinking that following those safety procedures is too expensive and slow. But consider this. A serious on-the-job injury costs an employer about $50,000 when all the costs are added up. The economic impact of a fatality is much greater, not to mention the emotional devastation, shock, and loss of morale that occur when a coworker is seriously injured or killed on the job. While cave-ins cause the most fatalities, there are other hazards associated with trenching and excavating. Some hazardous gases, like hydrogen sulfide or sewer gas, are heavier than air and can gather to fatal levels in trenches. There are crushing hazards from machinery and heavy equipment. There is often a danger from disrupted utility lines. Avoiding and preventing all the possible hazards is the key to keeping you and your co-workers safe. When it comes to trench cave-ins, there are some myths out there that we need to debunk. Myth: I can hear it coming. Fact: many cave-ins make little or no sound at all before they occur. Myth: trenches usually collapse in the morning or afternoon. Fact: data on cave-ins shows no connection to time of day. Myth: virgin soil will not collapse. Fact: while previously disturbed soil increases the risk, so-called virgin soil does not guarantee safety in any way. Myth: collapses usually kill inexperienced workers. Fact: again, fatality data says that is not the case. Myth: if the trench collapses, we can just dig the guy out with the backhoe. Fact: if he's not already dead, experience shows that you are as likely to kill him with the backhoe while trying to dig him out as you are to rescue him. Myth: I can outrun a collapse. Fact: a falling trench wall can move at about 30 miles an hour. Many fatalities have occurred with people trying to outrun a collapse.
Since 1981, I've responded to between 30 and 40 trench collapse incidents in Tennessee and Kentucky. And this is both in my role as a rescue officer with the rescue squad in Knoxville, as well as my duties as a flight paramedic and paramedic supervisor at the University of Tennessee. In trench collapse incidents, fatalities are very, very common. Proportionally of the incidents I've been to, I would say easily 75 to 80% are fatalities, and the balance being actual rescue operations. In different trench collapses, we've seen people face up, we've seen them face down, facing the wall in running positions. We've seen people trying to scramble up ladders. But the common denominator is none of us can go from a standing start to 30 miles an hour. And so the soil typically wins. It really depends on where the incident is and what the local assets actually are. I mean, you can look at response times for a trench collapse team in some areas to be as much as an hour, 2 hours. The soil on your body acts kind of like an old carnival Chinese finger trap. The more you struggle against it, the tighter the soil particles actually move around your body. But it's also a function of weight. A cubic foot of soil weighs anywhere from 75 to 150 pounds per cubic foot, and the average trench collapse is anywhere from 1.5 to 3 cubic yards. So you're looking at several tons of material, and it's just physically impossible to move that much weight. He was working in a trench in a nearby community, and he was doing a sewer line repair. And he actually dove for the ladder, but the impact and the weight was such that it actually drove his legs through the rungs of the ladder, and he was intertwined with the ladder. And he ultimately lost one of his legs due to the traumatic injury, but also to the secondary infection from exposure to sewage.
In order to comply with OSHA regulations, trenching and excavating jobs require a competent person to be on site. There is a precise definition of a competent person in the OSHA regs. For our purposes, it is someone who has been trained to recognize hazards and has the authority to stop work and correct the situation. Simply watching this video will not make you a competent person. You have to attend a training class for that. This video will familiarize you with basic safety procedures for trenching and excavating. Anytime workers are in a trench deeper than 5 feet, protective systems must be used. And protective systems in trenches deeper than 20 feet must be designed by a registered professional engineer. There are 3 basic types of protective systems for trench work: sloping and benching, shoring or supports, and shielding, commonly called trench boxes. Sloping means angling the trench walls at an incline. The type of soil determines the required incline of the slope. Benching means a series of excavated steps in the trench wall. Again, the soil type determines the bench configuration, or if benches may even be used. Data tables are available to help with these decisions. If you're unsure about the soil type, the side should be laid back on a slope of 1.5 horizontal to 1 vertical. Shoring means using timber, hydraulic, or other bracing on the trench walls. Again, there are tables that help you select the right size shoring for a given trench in the TOSHA standard. Shielding means using trench boxes. These boxes are built to withstand the forces of a cave-in. This protects people working inside the trench box. And like other systems, there are data tables that can tell you the maximum allowable depth for a given trench box based on the soil type. There are now stackable trench boxes, but remember, a trench box will only protect you if you are inside the box and using the box according to manufacturer's instructions. It does no good if you work outside the box. A trench is no place for outside the box thinking. There are different types of soils, and some are more prone to cave-ins than others, but typically soil weighs between 1 and 2 tons per cubic yard. This is about the weight of a small pickup truck. In a typical trench collapse, about 3 cubic yards falls into the trench. That's over 7,000 pounds in a very small area. That gives you an idea of why it is unusual to survive a trench collapse. The soil is so heavy that someone who is covered cannot expand their chest to breathe. Suffocation is often the cause of death in a cave-in. OSHA classifies soils into 4 classes. Each class requires different safety procedures. It's the responsibility of the excavation competent person to know and recognize the different types. The soil categories are stable rock, which is difficult to excavate but is the least prone to cave-in. Type A soil is previously undisturbed, cohesive soil that, when tested, has a compressive strength equal to or greater than 1.5 tons per square foot. It typically includes clay, silty clay, or clay loam. Type B is a cohesive soil with a compressive strength of less than 1.5 tons and typically includes granular soils such as angular gravel, silt, or silty loam. Type C is soil with a compressive strength of less than 0.5 tons per square foot. It includes gravels, sand, loamy sand, and also any seeping soil or submerged soil. There are also several visual and manual tests that can be used to determine soil type. An excavation competent person has to know how to determine soil types. To make their jobs easier and safer, some contractors always assume all soils are Class C. This means they always use safety precautions designed for the worst possible soil conditions. They err on the safe side. Here are the most common causes for trench failure. Failure to provide a protective system like sloping, shoring, or using a trench box. Soil fissures or cracks in the ground. Prior disturbance. That means the soil where your trench is located has been excavated before, and previously excavated soil, also called previously disturbed soil, does not have the compressive strength or cohesiveness of undisturbed soil, which means it collapses more easily under pressure. Vibration from equipment or automobiles in the area can cause a cave-in. Water. Water leaking from the sides of a trench weakens the trench walls and can lead to cave-ins. Freeze-thaw cycles can loosen the weakened soil. Open time. The longer a trench is left open, the more likely it is to collapse. Complacency or disregard for safety regulations can also lead to disaster. A surface encumbrance is anything along the sides of an open-cut trench or excavation that creates a hazard for workers in the trench or topside. This includes equipment, gravel, pipe, trees, poles, sidewalks, foundations, or any other structures. Surface encumbrances must be removed or supported. A spoil pile is the material that is removed from the trench. Spoil piles must be kept at least 2 feet back from the trench lip. Here are some danger signs to look for. When you see these conditions, the possibility for collapse has increased significantly. Bulges in trench walls, fissures or cracks in the soil parallel to the trench, soil spalling off trench walls. That means flaking or chipping off in small pieces. Water seepage from the sides or bottom of the trench. Large rocks embedded in trench walls. These are not stable rocks. Undermined structures including poles and trees. Exposed utilities. Unsafe actions, which means doing something that is inherently dangerous to yourself or others just to save time or effort, like working outside a trench box or working underneath a suspended load. Speaking of exposed utilities, Tennessee law requires you to determine the location of any utility installation before you begin excavation. The Tennessee one-call number is 800-351-1111 or 811, and it's a free service. You're required to notify Tennessee one-call at least 72 hours prior to digging, and your markings are good for up to 15 days. Depending on the situation, you may have to protect, support, or remove exposed utilities. All trenches 4 feet or more in depth must have a means of exit within 25 feet of all workers. This can be a ladder, stairs, or ramps. If a ramp is used for equipment as well as people, it must be designed by someone qualified in structural design. Employees may not work under any load handled by lifting or digging equipment, and employees must be protected from vehicles that are loading or unloading. Hazardous atmospheres are a potential in some excavations because heavier than air gases can collect in an excavated area. To determine if a hazardous atmosphere exists, you have to use a testing device. If you find a hazardous atmosphere, you will have to either remove the source of the hazard from the excavation, provide adequate ventilation, or provide respiratory protection before work can resume. In addition, rescue equipment must be maintained on site if a hazardous atmosphere is present or could reasonably be expected to be present. If your excavation will be exposed to vehicle traffic, Federal Department of Transportation regulations require you to follow the Manual on Uniform Traffic Control Devices for Streets and Highways. This manual outlines the appropriate signs, barricades, and traffic flow patterns to use in your work zone. Also, you must use trained flaggers and wear the appropriate level of ANSI reflective garments. Employees may not work in excavations with standing water or accumulating water unless adequate safety precautions are used. These can include water removal, protective systems, and pumps. In addition, any surface runoff must be diverted or controlled so it does not fill your excavation. All workers should be removed during rainstorms. Any surface runoff must be diverted or controlled. An excavation competent person must inspect the excavation site and adjacent areas and protective systems prior to the start of work and daily thereafter. In addition, an inspection must be done when the following conditions occur: following a rain, when cracks or bulges are noted, when a spoil pile is moved, when there is movement by an adjacent structure, when any real or perceived danger is detected. So let's review. All trenching fatalities are avoidable. Every excavation job must have a trained excavation competent person on site who has the authority to stop work when they detect a hazard. Sloping, trench boxes, or shoring must be used anytime workers are in a trench greater than 5 feet deep, no exceptions. Different soils have different abilities to support a trench. Every trench 4 feet in depth or greater must have a means of egress, that's a way out, within 25 feet of where workers are present. Unsafe actions are very dangerous. Hazardous gases can gather in trenches. You must test for those if the trench or excavation is in an area where a hazardous atmosphere may develop. Vehicle traffic must be controlled and water must be controlled. And an excavation competent person must inspect every trench at least every day and more often when conditions change. And remember, you must contact Tennessee One Call at 800-351-1111 or 811 at least 72 hours before you dig.